Before watching this video, I'd recommend that you watch my video on permutations and combinations, because what we're going to do is try to write down binomial coefficients using combinations. So, using the binomial theorem, write down the first four terms of a plus b to the 12. Now, using Pascal's triangle in this case, it's not going to be a good idea because we're going to have to write out about 12 lines of Pascal's triangle. So if we wanted to expand a plus b to the 12, it would take a long time. What would we do if the power is like 20 or 30? So we really need to look at a different method. So consider the binomial expansion of something really simple, like a plus b to the 4. This one we could use Pascal's triangle. Running out the four lines of Pascal's triangle, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, etc. This is the line that we want. So a plus b to the 4 is going to be a to the 4 plus 4 a cubed, so the power of a decreases and we introduce a b, plus 6 a squared b squared plus 4ab cubed, and we stop when we get to b to the 4, which is the same power of the expansion. These are known as the binomial coefficients. This one is in fact 1, and this one is in fact 1 as well, which comes from like Pascal's triangle idea. Okay, notice that the powers add up to the same power of the original expansion. Now, what are we normally doing when we would just do this normally with normal algebra by expansion? Well, we would have a plus b times a plus b times a plus b times a plus b. Now the first term would just be very simple. It comes from a times a times a times a, which will give me a to the 4. And the last term just comes from b times b times b times b, which gives me b to the 4. There's only one way that we can actually do that. But what's interesting is to look to see how we'd actually form this term. So the first term is a to the 4. Right, to get 4a cubed b, we need 3a. So it's a times a times a times b. That's one way. A times a times a times that b. That's the second way. A times a times a. A times a times a times that b, and then a times a times a times that b. So what we're doing is we want 3 a's, and then we need to multiply it by 1 b chosen from one of the 4 brackets. That's what we're saying. So we're choosing one thing from 4, so that is going to be 4c1 a cubed times b. Right, for the this term here, we're going to need 2 a's, and then we need to multiply that by 2 b's chosen from 4. So 2 a's multiplied by 2 b's chosen from the 4 brackets, and that is 4c2 combination, and that will give me a squared b squared. For the last one, we're going to just want 1a and then 3b times 3b's chosen from any of the 4 brackets will give me that term. And that gives me 4c3ab cubed. And the last term was b to the 4. Okay, so these are the binomial coefficients found by using combinations. Okay, so just pause the video if you're not sure, have a think about what's been written down there and see if you can think about it for yourself a little bit before moving on. So the first term is we're choosing no b's from 4, and therefore that will be 1. And in this term here we're choosing 4 from 4, which would again be 1. So we don't normally write these two in. These are known as the binomial coefficients. It's also worth noting here that this is the same number as this. Okay, there's lots of symmetrical things in the for binomial coefficients. So 4c1 is the same as 4c3, and in general, NCR, here n is 4, r is 1, it's the same as 4c n minus r. So n minus r will be 4 minus 1, which is 3. So in general, this is true. So a plus b to the 4 is that. Can we now just sort of come up with a sort of a general formula if we've got something like a plus b to the n? Notice one thing, ascending powers of a sorry, I want to correct myself. Descending powers of a, the powers of a are getting smaller, and ascending powers of b. If you consider this one to be b to the 0, then these are increasing. At the end here we've got a to the 0, which is that these are actually equal to 1, so we don't bother writing them in. Okay, so in general, if we wanted to expand something like a plus b to the n, this is what we want to do. We know the first term will be a to the n. The next term would be nc1, whatever n is, c1, and the power would decrease of a will decrease by 1, so the power will now become n minus 1, and we introduce a b. The next one would be nc2. We would now have 1 less power than this one, so it now become a to the n minus 2, b squared, plus nc3, 1 less power of a, so it's a to the n minus 3, b cubed, etc. And then we'll carry on up to, we would stop when we got to b to the n. Right, now in here there's what's known as the general term, which we can get by looking at the pattern n, and instead of using a number here we use a letter r, so it would be ncr. Be a to the n minus whatever the letter is here, so it'll be a to the n minus r, and b to the same power of whatever number we have here, b to the r. Now this is known as the general term for binomial expansion, and it's very, very useful in helping us to find specific terms or specific coefficients of a certain number term in the sequence, where NCR is n factorial, n minus r factorial, r factorial. Okay, so this is sort of a general formula for binomial expansion. These numbers can normally be worked out on a calculator, although there are different ways of doing it, which we can look up in another video. So if we go back to our original problem, which was a plus b to the 12 and the first 4 terms only. So n is 12, so that will be a to the 12 plus 12c1 a to the 1 power less a to the 11, b to the 1, same number as here, plus nc2 a to the 10 b squared, notice this number is the same here, plus 12c3 a to the 9. And we would stop there, b cubed, sorry, and we'd stop there because that's where the we only want the first 4 terms. 3 dots indicates that it carries on. We just need to work these all out on our calculator. So the first one's a to the 12. This is 12c1 we should know is 12a to the 11b. And then perhaps we can need to use our calculator. 12c2 is 66, a10 to the b squared. And 12c3 is 220, a to the 9b cubed. Okay, so this has been a video to show you how to find the general formula of a binomial expansion. I hope you've understood, and I thank you very much for watching.